Oh boy, you are seeing the carnage of me reviewing the Z1. This is going to be a long video. If you do not like long videos with all the gritty details, this is not going to be the video for you. I personally like long format content, but be warned, this is not going to be a short boy. First of all, let's start with the unboxing. As usual, the Makera packaging came out very neat. Everything was packaged with a bunch of foam, including the Cyclone. The cardboard boxes were also reinforced with stiff L brackets. If you receive this product, I don't see any problem that this unit is going to arrive damaged at your home. The only thing I have noticed is that the front lid, however, has a little bit of a rubbing going on from the packaging inside. Now the Air had the wrapping inside with plastic. The Z1 didn't. I believe this is because this is a beta unit, so here is your disclosure. Makera has sent this Z1 for me for free to test out. However, this is a beta unit and all the things that I'm going to say are subject to change. Now, while Makera has sent these products for free to test out, no money exchange hands, so I can be as unbiased as possible. But we do have a sponsor today, and that is going to be PCBWay. So massive shout out to PCBWay. If you want to see what I can do with these machines and compare it to a professional CNC shop, then make sure that you stick around, because at the end I will compare my work to that of PCBWay. Alright, ladies and gentlemen, are we ready for probably my longest video on YouTube? Let's go! And here we have it. This is everything that you can get from the Makera Z1 if you are backing the complete Kickstarter, or if the Kickstarter is done when this video is going live. Everything you can purchase in the full bundle that comes with the Makera Z1. There are some key differences we can already see between the Makera Air, the one we have reviewed last time, and the Z1. We can definitely see some cost cutting. With the Makera Air, you got this box, everything that you need to fasten your objects, plus your first milling bits, changing out colors, and all of that is in here. And with the Z1, everything is coming in plastic bags, and you will have to manage that on your own. Small little difference, but this is very nice to have. So that is already one place they have done some cost cutting. The laser seems about the same as the Carvera Air. The wasteboard this time is actually very different, and I kind of like it. This is a very dense and hard spoiler board, which is not the case with the Carvera Air. With the Carvera Air, you are counting on these smaller cardboard feeling like spoiler boards. This one seems to be a very highly dense type of material, which is going to make fastening your stuff way nicer than with the older one. For instance, with the Air, if you were tightening it on one side, the cardboard could lift on the other side. That is not going to happen. This is very dense and almost feels like wood. So this is already kind of an upgrade in my opinion. The new panic button is definitely also another way to cost down. With the Air, everything was nice, feeling sturdy, made out of metals, and this time they have chosen for the plastic solutions. They still managed to get a rotating Z-axis in there. If we are going to compare it with the Air, this chunker is quite hefty. And if we compare it next to each other, we can definitely see there is also some cost cutting going on. Now, the build envelope in the Z1 is a lot smaller than the Air, so they had to do something to be able to fit this one out. So if we are going to compare it, we can see that the part that is holding in the workpiece from the other side is a lot thinner. For the rest, everything looks quite the same. We had a little bit of shipping damage. One of those little stops on the back to cover up the ports. Yeah, that plastic part snapped. What we also could find is that this lid right over here is quite flimsy. Now, they did tell me that the hardware inside this machine is actually pretty definitive. The only things that are going to change or should change are some of the cosmetic designs. Apparently also the lid, they are doing something with the lid. I think some kind of metal reinforcements right here in the bottom will help with the sturdiness. So the tolerances on the lid seems to be not that perfect. You have to give it quite a squish to get it over the outer lip right over here. Like I said, these are going to be your pre-production units. Who knows what is going to change, so this is also not kind of a review. I cannot review the pre-production unit. But apparently the hardware inside of the Makera Z1 is definitive, and I'm going to do something different from all the other YouTubers. I'm going to grab my Makera Air, and we are going to do some head-to-head milling to see which machine is capable to do what, and what the limitations are going to be in comparison with the Z and with the Air. For the rest, everything is kind of the same. The quick release right in here is the same as the Carvera Air. You can switch out the colors and the colors for bigger bits, so that is going to be very comparable with the Air. Something different with the Z1 is going to be the dust extraction. With the Air, except for the shroud around your milling, there is no real extraction. With this unit, everything falls down to the back, and right here in the back there is a hookup for our dust extraction, which we are going to talk about at the end of the video. What we also have with the Z1 that we don't have with the Air is that there is some kind of a built-in air assist. In other words, right here in the spindle, there is a little fan in there that will permanently blow on the object that you are trying to mill out. So you don't have to hook up an air compressor for this machine to blow out your chips, which is really nice. Right now you have to run a compressor. Those things make a lot of noise. They are expensive. This one has a built-in solution for your chip evacuation, which is a really nice feature to have. Also, some big changes I can already see is that our Z-axis is now not a closed loop motor like we can see with the Makera Air. Everything is closed loop, so you have monitoring on your positions, and if you are going to have some drift, the machine will go into an emergency stop. Most of the time it's your bit that is hitting something that it shouldn't, or you have some kind of a collision and the system will do an emergency stop. I can see right now the stepper motor right here on the Z-axis is just your regular stepper that you can see in your 3D printing devices. So you don't really have that ease of mind that you have with the Air, that if it's going to impact something or it loses steps, that it will intervene and stop your project. In this case, it is more a little bit of a hands-on product. Now, of course, everything has its price. The Makera Air comes in at this price and the Z1 right now comes in at this price. The Z1 is more than half the times cheaper than the Air, and still we get a fairly decent build volume inside, which is very interesting because everything I have milled so far on my Air that was not in the review could also fit in the Z1. Also this time I have kind of a project in mind that we are going to compare with the Air and the Z1. But before we are going to compare the Air with the Z1, I'm going to do some general projects just to see how this machine works and if I can find something out that is quite of a concern. Also, another thing that is quite interesting, this lid is making sound. So what is going to be really interesting with this machine, we have a mono block kind of a chassis. This part right over here, this part right over there, and everything surrounding is one piece of cast aluminum, giving it a very sturdy base for our Z-axis. Like I already can see, we also have other differences between the Air and the Z1. The Z1 is using linear rails instead of rods. We can see it right over here, and the bed is also on linear rails. The Air is on rods. This one is using your regular lead screws, while the Air is going to use ball screws. Apparently, from what I know, ball screws should be more precise than your regular lead screws. So this is also a way they are trying to cost minimize on the Z1. What I also noticed is that right here inside there are quite a lot of shavings. So they have tested this machine in the factory, and apparently they are going to do that with every machine in the future, that it will get a milling job to see if the accuracy is within tolerance, which is very nice because then you know that when you receive this machine, Makera has checked it for you, that it will fall within the tolerances. I think we have done enough of yapping. Time to do some little projects before we do the major comparison between the Z1 and the Air. This machine also has the ability to use Wi-Fi, Ethernet, USB, and even hardwired to your laptop. Now, because this is a beta prototype machine, these features are not all working. The Wi-Fi is working, but there are features I cannot test right now. So for instance, there is a USB on this machine, but right now with the current firmware, it is not supported. This should work on the products that you will receive, so I cannot test it. Now, I have tested that on the Carvera Air, and that seems to be working perfectly fine. I could easily charge my phone if I would put it in the stand. Not that I ever did, but I did test the USB power and it definitely worked. Now on the Z1, this is a feature that they have yet to enable. I got the emergency stop button plugged in, power on, and let's see what we have inside. It looks like we have booted up our printer. Now it's time to connect it to the Wi-Fi. That is going to be the same as the Air. There is a whole wiki on how to get this printer on your Wi-Fi or just get it connected to your laptop. So I'm not going to show you that, but I'm going to do that, and then we can do our first milling. There is also a new software suite coming up for the Makera Z1, and they are calling it Makerables, something like that. And you will be able to do any type of AI relief cutting just from a picture. That is also a feature that is right now in beta, but that should be included when this printer is going to get delivered at your door. Now, time to do some updates and see if we can make this puppy run. I tried to connect the controller to the Makera Z1 with the Wi-Fi. It works, but it has kind of a buggy behavior. I have relayed those behaviors to Makera so they can try to accommodate for that, because with the Air that is not a problem. If you are having the same problem and you are not able to connect it to Wi-Fi, the problem in my case is that my Wi-Fi name, so the SSID, is separated with a space. So if you are going to remove that space, like my Wi-Fi with a space or my Wi-Fi just all together, the one with everything together will connect to the Z1. So I can or change every device in my freaking home to the new Wi-Fi, or yeah, I hope Makera is going to fix it in the next software update. I think that is going to be a lot less effort. Also, something I noticed, there is no manual included in this ordeal. So that means that we are left to our own imagination to create projects on the Makera Z1. Now, before we do any machining, we also have this device right over here. So this is going to be the new Cyclone dust collector for the Carvera ecosystem. It is not only working on the Z1, which we are going to use it for in the next projects we are going to do, but it is also compatible with every other Carvera they are making. So that means also for the Air, and then for the bigger brother with the tool changer on it. So this is a newly developed product, and this is also including all the finalized material. We have a manual right over here, and here we have the Cyclone. Now, if I'm being honest, this is going to be the product I am most interested about. When I was doing the Air review, it was really apparent how much crap is going to accumulate in your CNC. So the Z1 not only now has the optional dust extraction, and it also has the chip evacuation. So these are two things that the Air didn't have. So this seems to be all built out of aluminum. It is super sturdy. So when we open up the top, this is also made of aluminum with a plastic insert. We also have a gasket right over here. Then we have a double latch that is going to remove this cover. We have a little membrane, and then this is going to be the meat and potatoes of the Cyclone system. So this is going to be the particulate and carbon filter. This is all combined, and when I shake it, you can hear the balls rolling around. So this is a consumable. You will have to replace it after a set amount of hours. This is going to be the dust outlet. Then we have our filter, and right over here is going to be our fan. We also have a QR code to scan if we need to do any maintenance. Then at the bottom we have two latches, and then you should be able to pull off the top. And this is going to be all your hosing to hook up to the Carvera. We have a cable to connect to our CNC, long enough tubing, a power cable, and some cotton. Not sure what we are going to use that for. And this is going to be the website if you scan the QR code. So you can see right over here in the manual, these little cotton balls are for your lasering filtering. We just plug it in, we can see a blue light. This is going to be idle, and now it is going to be controlled by the CNC. But if we turn it, you have manual control. This is the exhaust port, and these are for show. Okay, a lot has happened and I have the bed right here in my hands. You have seen me do some thinkable things, and it was because the little dowel pins, so you get a baggie with a bunch of dowel pins, we had to insert dowel pins to get the rotating fixture on here secured. This is just how it should be by stock. Now, it was a little bit tight, and I was thinking like, why not hammer the dowel pin in? Massive mistake. It didn't come out again. So yeah, I screwed myself over. So I tried to drill it out. Yeah, those are hardened steel, not going to happen with a regular drill bit. So I stopped that, and the only thing that was easy and fast enough for me to do was drill a hole right here in the back, then take something like this, a punch, and then just try to hammer it out successfully. So you can see it here, we have cut it off. Yeah, so here is the little hole I made to be able to punch it out. Yeah, this is certainly not my proudest moment, but if life gives you a pain in the ass, you take some cream, and right over here is something very interesting that I want to show you guys what is going on underneath this bed. At least something positive, right? So this is going to be your bed mounting system, and we can find 3D printed spacers. These are sitting in the fronts of these bearings, and these are going to scrape off all the junk from this linear rail so they don't come into this bearing. We can see they are doing it on this side and they are doing it on this side. Now, unfortunately, these are plastic. These are going to be subject to loosening up as there are no heated inserts in there. What we also can see is they are trying to put some cotton in here, but this side already destroyed itself. I believe it is by reaching this end, and then it just pulls off the little cotton wad that is sitting in there. Then also something very nifty, this is where the bed is going to get pulled back and forward on. So we have a steel band that is going to cover the lead screw. Then we have this contraption right over here that is mounted to the set lead screw. And then we have this steel band. This steel band is going through the mount, and when we move this steel band is getting lifted by this device, trying to protect the lead screw down below. So that seems to be very clever. The only thing I found concerning are going to be these 3D printer blocks. When I was removing those bolts, I could already feel that most of them on these plastic blocks were loose. So I think they are better off making them out of aluminum, or maybe we should mill them ourselves. Alright, that is going to be for another time, because I want to end up this video and we still have a bunch of work to do. Now, there are also some things while we are complaining about shit that I destroyed. So the tolerances on the bed weren't great, the dowel pins didn't fit, that is the short story. So I had to drill them out with the 4mm, and now the dowel pins are going in like it should. The machine itself is working mostly fine. This is going to be the Makera software. I have no clue what happened over here, so I tried it again. We can see that this is absolutely working. Now, there are some weirdness going on with the software. For instance, if you want to connect to the Wi-Fi, you cannot have a spacing in your naming, and the same is going to be true for the files. So if you have a file name that is test space this stuff, then the space will generate a weird square character, and that will interfere with the machine. So if you are going to try send the code from the laptop to the machine, the printer will not start. So that means that you will have to do everything without a space for the Wi-Fi and for the file transfer to the machine. If you don't do that, stuff is not going to work, and I'm very sure with the Carvera Air that is not a problem. Also did some aluminum stuff. It worked very fine. I actually bumped up the feed speed to 700 instead of 500. And yeah, from what I can measure, these are working perfectly fine. Now, I was trying to do some rotary stuff. I'm going to remount the bed. So the bed's super nifty. We have a little cable that is super easy to remove. Installing it should be equally as easy. Now, let's hope that this was the last time I had to do any tinkering on it. All right, fingers crossed. Well, I was just about to mount this block right in here, and yeah, it's missing a chuck. Apparently they forgot to mount it or something. So yeah, what I'm going to do is grab the one from the Carvera Air. It seems to be just bolting on or something. So I removed the chuck that is sitting on the one of the Carvera Air, This one over here, this one now has a bolt sitting in it that I cannot remove because we needed to have the counter leverage to remove this one. This one just twists in, you turn in a bolt in the middle, and then you can put in a hex head like that and give it a leverage so you can twist off your chuck. Now, this one is off. So this one doesn't fit. It seems that the axle that is sitting on the chuck for the Carvera Air is a lot bigger than this one. It figures everything is a lot smaller over here. So I will be sending an email. Where's my chuck at? This was the box. This is what is sitting inside. And this one is capping everything off. So it looks like the factory has made a little whoopsie. I forgot to install the chuck on my unit. So I'm afraid that for this video, we will not be doing rotating axis thingies, unfortunately. Also, on a complete side note, this vise right over here from Inception Machines, this is a company from the UK. I have now used it for quite a while, and there are some teeth right over here to hold in softer workpieces. I have to say, I absolutely love this vise. It is not cheap. It's going to cost you anywhere between 150 and 200 euros. Because being from the UK, if you want this, you will most definitely will have some import taxing going on, which is a shame. It makes it more expensive than I want it to be, but this thing is just an awesome piece of equipment. The machining is top-notch, the finish is top-notch. I cannot say good enough things about this vise. Now, I have been looking on the website of Carvera, and they are selling their own style of benchtop vise clamps for your little CNCs. That is probably also going to be a little bit cheaper. Now, I don't have that vise in my possession. The only difference I can see is that the feature you can see right over here, Carvera is probably not going to have those. Alright, so lasering seems to be working fine. We don't have air assist right now. I'm not sure how you are going to hook up air assist. There is no inlet for that. So you are banking on the air assist fan inside the printhead. And we can see on this part that we do have some smoke or flashing over from the laser, making it a little bit less clean than it should be. I believe a way to fix that flashing is just to give it a wee little sanding. Let's wipe off the excess dust, and it is looking way better. So a little bit of sanding after the laser really fixed it on this epoxy board. Now, talking about these epoxy boards, you should not laser on these. These are very toxic, and also Makera is very hesitant on you on using those. They do not recommend it at all, but I did it anyway. And the reason is going to be, I wanted to use this bad boy right over here. So we did what they recommended. We have put in a cotton wad. This one right over here, let's take a closer look. As you can see, it took up a lot of the junk. We can also see it on the other side. This is now completely saturated with the toxic dust we have from the epoxy board. We not only have this piece of cotton, there is also a carbon filter and all of that in here. And I have to say, looking at my gauge, we started at 0.55 of a total VOC in this shop, and we have risen to 0.65, so it barely did anything to the air quality of this room. I have done this testing on the Carvera Air, and it was horrible. It came all through the shop vac, the HEPA filter. It didn't do anything about the smell. It was absolutely horrible. Also the reason why you shouldn't do it, but this is one of the smelliest things I have done in the shop for lasering. And I can tell you one thing, that this thing does a formidable job of keeping away the smells from this machine when you are lasering, which is actually one of the best tests I could think of. So the milling quality is absolutely on point. We have 0 defects on this little test piece. And on the back we have my friend that played with the super glue again. I have also done a calibration test. This should be 25.4 and it is spot on. This has been 6061 aluminum. I don't feel anything on the finish. It is as smooth as I'm going to get it. I would even dare to say it is a wee little bit smoother than I had with the Makera Air. Now for the next test, I'm going to clear everything from the table, and the Z1 is going to get company of its bigger brother, the Carvera Air. And we're going to do a little head-to-head with these solid copper blocks. Here we have them side by side. We have the Air and we have the Z1. I'm going to take some measuring devices, and before we do all the testing, let's see what the biggest differences are between the Air and the Z1. Let's start with the bed first. We have about 29 centimeters versus 19. So we are losing 10 centimeters between those. 20.5 and 19. So in the depth we keep the same. We are losing only half a centimeter. It is mainly in the width that we are losing quite a lot on the Z1. Around 11 centimeters versus 13. So the spindle height on this one is 13 centimeters. This one is 11 centimeters. The difference between the linear rod and the linear rail is absolutely massive. So the rod is 20 millimeters, and I can see on the marking that this is a 12 millimeter rail. Both of these have the quick release, only I found this one to be a lot smoother than this one. Dust extraction is done with this hose and this dust shoe. On this one we don't have it, but we have voids right over there that is sucking up all the dirt. This one has an air assist that also works with the laser. This one has a fan in the tool head blowing away the chips that way. They both have the same laser probes. The calibration stop on the Air is a little bit different than the one on the Z1. And if we are looking at the hood of the Z1 is actually a lot higher than the Makera Air. The only difference is going to be that this one can hold its weight at different locations, while the Air one can do this, or it only closes completely. The start button and emergency stop is on top for the Air, while the emergency stop is on the front for the Z1. Now, unfortunately, during a tool change, it happened that I touched this button, which is going to act as an emergency stop. So what I wanted to do was open up the lid so I could change the bit that was sitting in here. And instead of just grabbing the lid, I also bumped the emergency start button right here in front, triggering an emergency stop, which meant that I had to do this milling job once again from start or remove the part that was already done. So I think the location of the start-stop button is a little bit unfortunate in this one, because every time you want to grab it, the chances of you bumping into this start-stop button is quite high. While in case for the Air, there should be no reason that you are bumping on that one by accident. Also a big difference, the spoil board on the Z1 is a hard-pressed material, while the one on the Air seems to be made out of some kind of MDF that is a little bit fragile. This one is solid as rock. To keep out the chips, they are using some kind of a plastic wrapping. Now, spoiler alert, these don't do a great job. While we could see by my happy accident that this is doing a way better job of keeping out all the debris out of the spindle. The linear rails, however, are subjected to the crap that is going to be in your CNC mill. Then the overall size, the Air has an opening of 50 centimeters, while the Z1 only comes in at 35. The height of the machine seems to be the same. The depth of the Z1 is 46 centimeters, and the Air seems to be 47. So the depth of the machines is only about 1 centimeter. So all by all, this machine is more than half as cheap as the Air and still provides you a big enough build surface. If you compare it to the Air, we only are losing a little bit of the width. All the rest seems to be kind of the same. Also, something we didn't talk about, the Z1 right over here has a camera. However, the camera seems to be of a really poor quality. So the only thing that you're going to get out of this camera is just looking from a distance if the machine is still running, in my opinion. The details are not good enough to see if your bit is broken or if you're having a disaster while it is doing remote milling. So in my opinion, you you are still not sure enough if this machine is destroying itself, well, with the Air, you have the little bit of trust that you get from the closed loop stepper motors that are going to do that for you. When it notices that you are screwing up with your code, it will act as an emergency stop. One time I had it happening right over here. It was just pushing a bit all the way to the aluminum button and it triggered an emergency stop because it started to lose steps. Also, something that is not coming with the Z1 is going to be this edge finder. This is going to be a very handy tool if you want to use the same block, you want to rotate it on your build plate to do milling on other sides. This is going to be very handy to get a very precise location of your current workpiece. Right now, this is not standard delivered with the Z1. I have, however, seen on the website that they now have a 3D probe, which means it is just a little pin that will feel the surface and the sides a little bit like this is doing, but way more smarter, and that is going to give you the perfect location of your workpiece holding. In the meantime, I have this one and I'm going to try to find out if this also works plug and play into this one. This is going to be my test setup for today. This tablet is going to be connected to the Air and the laptop will be directly connected to the Z1 because this is on its own network because that doesn't work right now. So the goal of this setup is to do some surface passes. We are going to mill the top surfaces to the final thickness, which is around 5 millimeters for the copper blocks. So it actually did it, but the quality of the top surface is looking like absolute ass. So this is going to be 700 with some changes. We have done some strategy changes in order to try and help it ramp it better in the material. I'm going to put my finger on it. Here we go, 700, yeah baby! Let's take a closer look and see how the finish is. Seems to be better, so it's not all climbing. Time to go faster! There we go, 1100, let's go! Yeah, that worked. Half a millimeter. Ja. So this right over here was 1 millimeter deep at 500 millimeters a minute. I think we are reaching the limits of the capabilities of this system. And why do I say that? Because when the mill was reaching this point, it almost completely died doing it. So I'm going to call it, this is probably going to be somewhat of the maximum, 500, 1 millimeter deep. And I have to say, the surface finish is absolutely horrible. This is what the setup would look like on the Air. We have our cord right over here in the place of our probe. Then we have our special bit, and then we have our little probe thingy right over here. That is magnetic. You will need that in order for this metal block to contact this metal block so you get the signal. So what you need to do is this thing needs to hover right over this. You have a corner piece sitting like that, and now I'm going to ask the software to do the XYZ offset calibration, and we're going to see if the Z1 is capable of doing this with the probe of the Air. And indeed it detects the probe, which is fine, because right now we should have the perfect XYZ offset. This will be our first test cut, 500 millimeters a minute at 0.5 millimeters of cut-off depth. This is super interesting because these spindles are only differing about 50 watts, yet the difference is tremendous. 9,000, 8,000, 7,000. That is about a third of what we were doing previously at the 0.5. You're going to hear it. And there we go. It bogged down. Yeah, we have all seen that. The spindle just died on entrance. So ramping, very important, but the biggest takeaway is the Carvera Air had 1 millimeter depth of cut before it started kind of bogging down. This one just, yeah, it dies even at 0.15. What it seems to be missing is just a pair of balls. And with that I mean torque. You can hear the motor try to compensate, spinning up the bit and trying to compensate the dropped RPM. Now, that process is way too slow. with this motor, which makes me believe that we are missing quite a lot of balls into that spindle motor. So there is going to be your biggest difference between the Air and the Z1. It is going to be spindle power. The number doesn't seem to be that big of difference, but in reality it does seem to matter a lot. So what we could see is that there is no safety protecting you from your spindle just completely bogging down. Even worse, we could see that the bit was trying to just pull against the copper. This will be definitely a bit breaker if you screw up your feeds and speeds. Happy to have cleared that up for you guys. So also big difference between the Air and the Z1 is the closed looper system of the Air will protect you when you fuck up your program, and the Z1 is not going to do that for you. These are going to be the two blocks. The thick one comes from the Z1 and the thin one is from the Air. This has done the most amount of milling. So these are the results of the Carvera Air. We can see that the consistency of the milling is not optimal. We see a lot of chattering going on. So the same thing for this one. And you can see it. Wow. The difference is day and night difference. Now, we can see, very interesting, on the x-axis is a lot more chattering than on the y-axis. So what I think is that the y-axis on the Z1 is a lot more stable than the x-axis. Now, CNC experts, it's up to you to tell me if I'm right or wrong. Putting these two next to each other, yeah, there is no denying that the Z1 is doing a way better job than the Air with the same speeds and feeds. Now we have just done face milling because I am preparing to make water blocks out of these examples. So I'm going to put this one in the Z1, so it has to do more milling than the Air, and then we are going to see the quality difference between a milled water block on the Air and a milled water block on the Z1. Here we have it, two finished up pieces. One set milled on the Air, one set milled on the Z1. And the results are actually fairly interesting. We had a really good finish on the Z1 when we did the rough milling of the original block. But however, when we started to do the very tippy toe of this detail, then we also could see the same problem as with the Air, which is going to be a very rough outer finish surface. Let me show you. So this is one of the blocks and this is horrible of a finish. So what happened and why did the Z1 all of a sudden provide worse milling results? The answer is very simple: heat. There is no way for this Z1 to cool down the copper enough to get a clean cut. That means that when you are doing the milling, the copper really heats up, it starts to get gummy, and instead of milling away the surface, we can see it right over here, it starts pulling on the copper. And also that giveaway of that happening is going to be these long strands right here in my hand. Now with the air, we can use external compressed air. That is going to cool down your bit and your workpiece. With the Z1, unfortunately, we only have a fan right here in the spindle, which means it is going to recirculate constantly the hot air. What did help, however, is turning on the exhaust thingy to get all the copper away and also pulling in fresh air, and we can see it right over here, the second block that was sitting next to it. So when I turned on that external exhaust fan, the copper already looked way better. The compressed air did also the trick. It cooled down the object, giving us an overall smoother finish. In the beginning I was thinking, what the hell is going on with the air? The 6mm bits on this copper is not a match. Maybe a single flute, but the 3 flute with the 6mm, it is just pumping so much heat into the copper, giving us an awful result. So smaller bits, single flute, and then we have the cooling capabilities of this both systems. And we can see in the long run, the air did actually work better out than the Z1. Although the initial cuts of the Z1 look better than the air. And that difference is going to be right over here. That is going to be the monocast aluminum frame of this Z1. Is so compact and so sturdy, it is all a bit stiffer than the air. And there you can see with material as copper, it is very unforgiving, and we can see that the frame structure of the Z1 seems to be slightly stiffer than the air. Also, another cool feature we can see between both is the amount of mass these are generating. Let me show you. So this is the amount of mass that the Carvera Air is producing. This has been vacuumed for 3 times during the milling, and we can see this is horrible. The story changes with the Z1. We have a little bit of piling right up here, but all in all, this machine is a lot cleaner. This is because of the slowed angles. These are going right here into a collector, into the vacuum, and these are gone. Now you could say that you put on the hoodie thingy, but as long as you are doing any type of facing without deep pockets, this is going to be the mess that you will expect. Now, I'm not opposed to cleaning up the surface. It is about a minute of vacuuming and everything is fixed. What is also going to be interesting is the dirt on the bottom. Let me show you on the air. This is the amount of junk that is coming out of the air, and this is the amount of junk falling out of the Z1. Because we need a top plate for our copper blocks 6061, we are going to start with a 6mm, see what is going to happen, step down, and you will see what the end result will be. Let's start the facing with the Z1 and see how 6mm facing on the Z1 is going to turn out. So I'm going to switch back to the 1/8 inch or 3.175, I believe, because we had 2 cases of overheating spindle. So this boy right over here, it is very clearly that 6mm is just not going to work on the Z1. Unfortunately, so good to know for you, this spindle is not powerful enough if you are thinking about switching to 6mm bits. Okay, we have done the second finishing pass. This time we done it on the other side. We have used 2 different speeds. So at the bottom, the one we have done before was at 500mm a minute, 0.1 cut-off depth with the regular overlap, which is, I think, 69% of the bit size, something like that. The top side, however, has been changed to half the speed, which is going to be 250mm a minute, just to give me a feeling how much better the quality is going to get. Now, if you want to have a true finishing pass, unfortunately with the standard more easy cam of Makera, you cannot set up a finishing pass, or you have to put in a new pass and do it that way. It would be very handy if the pocket function would have a little tap on it to say, you know what, I want the last pass to have these parameters like the overlap and the speeds. Now, I have to say that the top side, it is a bit of a weird thing going on. This right over here is super buttery smooth, and this is feeling a little bit raw. This is also feeling a little bit raw. This has been milled way better than this. I have absolutely no clue, but this part is definitely feeling a lot better than the other side. The other side is feeling a little bit more rough than this side. We can also see there is a little bit more bit chatter at 500 millimeters a minute. If we turn it around, we have less bit chatter. We can also see that there is a little bit more polish going on. So this block is now ready for the final milling. Then we are going to use the same file for the Air and see what they compare to. The Air and the Z1. Can you see differences that are noticeable? In my opinion, these are looking quite the same. I would say that the Z1 is ever so slightly a little bit cleaner than the Air. So for milling 6061 aluminum, the Air and the Z1 perform about the same, I would say. Now we also have the bottom surfaces. This has milled with a 6mm and this has done with the 1/8 bit. And I have to say that the 6mm is feeling ever so slightly smoother than the one done with the 1/8 bit. So I think it's a little bit of a trade-off. What we definitely noticed doing all the testing with the copper and the aluminum is that the spindle power of the Z1 is going to be the biggest downfall of the system. We could see that every bit bigger than 1/8 of an inch is absolutely not going to be a great idea. Even with depth of cuts that are 0.05, we could see that the spindle was overheating or bogging down completely. So what I'm going to do now is clean up all these pieces to a finished state, which means that for the copper we will have to do some sanding. These are very rough as well on the Air as on the Z1. And then we can compare these to professional machined examples from today's sponsor, PCBWay. Alright, let's also look at the performance of the Cyclone dust collection. On this very coarse particle filter we can see a little bit of a white mist going on. This is probably going to be from cutting the epoxy board or CO2 lasering. The panel filter inside still looks very clean. So no coarse debris is reaching this coarse filter. Everything is staying right here in the bottom. And here we can see an absolute massive amount of copper and aluminum debris. We also have some epoxy crap going on. So yeah, if you want to know if the dust separation of the Cyclone is doing its job, I can say very well. Also something very important I want to say about this. This has been running close to 100 hours of continuous vacuuming and it has without one hitch. The only thing we had, and this was an error message, because believe it or not, the Z1, the port where you hook up your Cyclone dust vacuum, was clogged with all the chips we were making. And the system also has a detection if there is a clog or not, and then it will stop and it will pulsate the light around the knob, which is very handy. We had it happen once from the very coarse pieces of copper. After clearing that up, this puppy has run without one hitch. So this seems to be a very quiet on one hand and powerful dust Cyclone extraction. And I really don't see one thing that I hate about this Cyclone. Even with the CO2 lasering, it did a really well job of keeping out the smells out of this room. So in my opinion, totally worth it. It's a bit on the pricey side, but if you are doing a lot of CO2 lasering, this unit does a great job of eliminating the smells. Not completely, I would say about 98%. I was just finishing up my sanding work and this fancy box arrived at my door from today's sponsor, PCBWay. Now I could give you the whole spiel why you would use PCBWay. They not only make PCBs, they also do 3D printing and CNC milling. Not only that, the reason I picked PCBWay today is because I wanted to do something different. What's inside here is something I cannot do at home, which is going to finish up this copper project perfectly nice. So one of the options you can ask on PCBWay is how clean you want your result to be. And I have selected the option to have the cleanest as possible surface finish without bead blasting. And this is it. This is looking buttery smooth. Compare that to what I did. This part right over here. Yeah, this is a massive difference. Then let's look at the inside. The inside is going to be our giveaway on how the milling quality is. And I have to say that my quality on the inside of the block is not far off from PCBWay. So a gorgeous example. Now it's time to look what these parts are going to be, and these have a special surface treatment. This is one of my blocks, just raw milling. We just cleaned up the edges and that's about it. What's going to be in this packaging is super exciting because it will be a dead giveaway for what project we are going to use these blocks. And here we have them. This is one of the surface finishes you can pick from PCBWay. This is 6061 aluminum with an anodized surface. Then I took this one, I did the proper sanding to get all the marks out of it. This is looking perfectly nice. Why did I ask them to do this anodization? And it is going to be very easy. If I would pick this aluminum, I put it on the copper and I put it in the loop, we would have massive galvanic corrosion because copper and aluminum will react to each other. And in fact, you can already start to see where the copper was touching the aluminum, we have some discoloration. So this is how fast these two products are going to react with each other. Now, if you anodize these will no longer react with the copper, as we now have a layer on the aluminum to prevent stuff like that. So these are going to be the water blocks for the rhetoric. We have the green, and these will look very nice on our stepper motors. And this is going to be the difference between professional production and what we have done ourselves. I have to say, we have not done a very bad job. If we clean up our projects, I can definitely say that we can make it match to what a professional shop can do. Also, the copper blocks, if we compare them to each other, we can definitely see that if I do a little bit of a polish on these, then this is very close to what a machine shop can do. So if I have to compare professional made products against what we have done with the Makera Z1, I have to say that after some post-processing, we can get very close to the results of a professional machine shop. So thank you PCBWay for sponsoring today's video. If you are a new user of PCBWay, there will be a link down below and you get $5 off your first order. So I think right now it is time for me to put an end on this video. I have done some editing and we are closing near to 50 minutes of videos. Woof! Yeah, this is going to be a long boy. So for the people that skipped to the end, I want to know what I think about the Z1. First of all, is it as good as the Makera Air? I have to say yes and no. We find a lot of quality of life features in the Z1 that I really like. The sloped angle of the bottom, that is going to do your chip evacuation. It all slides down. Then you have the Cyclone, works perfectly fine. The only thing that we can see is that the chip evacuation fan and the tool head is a little bit on the low power side and the very heavy chips will not fly away. It does, however, do a fair enough job to get most of the chips out of your workpiece. Then the other part is going to be, we have a camera. The camera is usable, but if we look at it at software, the resolution is fine, but it seems to be overlighting the object, so you don't actually see what is going on with your workpiece. So while you can see if the job is still running, you don't see what is happening with your project. So I would like to see Makera do something with the tuning of the camera, so it is a little bit darker, so we can actually see what is going on. Maybe put a little sunglass visor thingy over the camera, or if it's possible, do some software tweaks. We can also see we have a little bit of beta user experience going on, like this top LED is a little bit flimsy, and if you want to get it all the way down, you have to give it a good, nice push to get it over the side lip. Now, they have said they would address it, but so far it is a little bit of an issue. We can also see that the clarity of the plastic is not good at all places. I would say that in front it is mostly fine, but we definitely see molding defects on multiple spots of this top lid. So this is also something they will need to look out for. Also another thing we had on the Air and also on this one, this came loose. The grub screw sitting right in there. I had to tighten it to get the rattling going away. And then we end up with the spindle itself. The spindle itself seems to be kind of a closed loop system. It has a tacho. It really knows what the spindle speed is going to be. However, we could see it will not intervene when the spindle says 0. We've done the testing. If the spindle is bogging down, this CNC is happy to continue whatever the hell it is doing and it will break your bits. So right now, this is not a hands-off user experience. I think with the spindle thingy that can be programmed in software, because if it reads 0, this system should trigger an emergency stop. Right now, it is not doing that. Spindle power also on the lower side, 200 watts, 150 watts. You would say it's only a fourth less. We could see that with 6mm bits, it hated it. It absolutely hated it. So I would say that the original bit size, so the 1/8 inch, is going to be perfectly fine for the Z1. Anything bigger is going to be wasting your money. If you are sticking to the 1/8 bits, we could see that the milling quality differences between the Air and the Z1 are very comparable. Most of it we lose on the Y, but the rest of this system is quite comparable with the Air. It is also a lot sleeker, the lights are a little bit better. We are losing a bit of quality on the lead screws and the linear rails. However, with all the testing we have done, we cannot see a quality difference between the Z1 and the Air. And I would even say that the Z1 initial cuts, when the parts are still really cool, did a better job than the Air. So while I could see that they did a lot of cost cutting, it did not come at the cost of performance, except for the Spindle. Now, however, Makera did an update thanks to the Kickstarter they are doing now. I believe it was around a $250 upgrade. They would convert this to a closed loop stepper system. Now, I'm not sure if this is going to be a thing for all units. It could be that it will be an upgrade kit that you will have to order when you purchase this machine. So right now, I cannot for sure tell you that all future models will have closed loop steppers, but I really would prefer it would have it. Otherwise, you will have to babysit the thing unless you have done the job multiple times and you know that the feeds and the speeds that you have put in this machine are not going to destroy it. Nonetheless, $250 more for closed loop, I don't think it's going to be really worth it. Right now, this is coming in at $1,200 US, probably going to be around the same in euros. And I would say this is a very capable machine to have in the shop. Now, the biggest question I'm having for myself, would I keep the Z1 or would I keep the Air? Right now, I am undecided. They both have their own unique charms. The Air is bigger, it is always nicer for the cases that you have to mill something bigger. Also, the rotary axis seems to be sturdier, although we couldn't test this one. Apparently, the rotary axis for the Z1 is the older version of the Air, which means that we don't have an harmonic gearbox and it is belt driven. Backlash concerns and all of that, but I have seen other YouTubers testing it and they do not claim that to be a problem. So that is also another way they have costed down the Z1. Now, these are all your optional extras for the $1,200. This is the only thing that you are going to get together with the standard mounting solutions, which are going to be the bolts and these clamps right over here. I would definitely invest in the low profile vise like the Inception one, or use the one from Makera. It is $70 or $75 to get one that will fit in the Z1, and in my opinion it is going to be totally worth it. The clamping on that is just way better than you can get with stuff like this. I kind of hate it. So right now it's time for you to comment down below, what is your opinion about the Z1, and would you prefer the Z1 or the Air for double the pricing? There is no denying that for half the price, this is a very capable machine, and if I have to recommend one of these two to you, it is probably going to be the Z1 to get your hands dirty in CNC milling to see if it's actually something you want to invest in further. Unless you are planning to do massive objects in there, but still there is a hatch right in there that you can remove. The same is true for the Air. If you want bigger pieces in there, then that is definitely possible, but I believe that most people will not do very big objects in the Air or in the Z1. So yeah, let me know down below what you think about the Z1, what you think about this very long format video. Personally, if I watch a video that I'm really interested in the product, I really don't mind to watch a 50-minute video. I actually like it because you get all the dirty and gritty details from a product that you can't get in a 17-minute rambling video. So that's gonna be it for me. If you want to purchase any of these two products, you can follow the link down below. It will earn me a little kickback on it. Just know that it is highly appreciated if you do so. You don't have to, then you just go to the website of Makera themselves. Also, big shout out to PCBWay, sponsor of today, to provide some parts so we can check it out, how it compares to the stuff we have done ourselves. And I have to say, I am quite pleased with the performance of both these machines. All right, that's gonna be it. Thank you for watching, and guys, I see you in the next one.